Hi, welcome to Physical Science 1.1 on states of matter. We're also going to be talking about how the kinetic molecular theory affects each. We're going to be talking about solids, liquids, gases, and plasma, and the transitions in between them. First of all, solids. Solids have a definite shape and a definite volume. This jar has a definite shape. It won't change its shape. I could break it, but it won't change its shape automatically. It also has a definite volume. It has a volume that it occupies, and it has a volume that it will also hold. The kinetic molecular theory of solids says that even on the molecular level, this solid is actually moving. The molecules are moving. They're held tightly together and they just sit there and shake or wiggle all the time. Okay? Liquids, on the other hand, like this bottle of water, liquids have an indefinite shape. Notice when I tilt the bottle of water, the shape of the water inside changes. It doesn't have a definite shape, but it has a definite volume. I can't make more water appear in this bottle. The kinetic molecular theory of liquids says that the molecules are held close together, but they have the ability to roll over and around each other. But they won't separate completely. Gases have an indefinite shape and an indefinite volume. Imagine blowing out a candle and the gas expanding to fill whatever container it's in. The kinetic molecular theory for gases says that the molecules bump against each other and move in all sorts of random patterns anywhere they want to. Gases will expand to fill their container. Plasma is the weird one for us. We're not used to plasma. Plasma is by far the most common form of matter in the universe, and that's because it is what makes up the stars and the space between the stars. So 99% of the visible universe is plasma, and plasma behaves like a superheated gas-like liquid. Now, when we talk specifically about water, if water is below 0 degrees Celsius, which is 32 degrees Fahrenheit, it is solid. We call it ice, but it is solid water. The molecular structure, the actual atoms themselves are the same no matter what the temperature is. But when the temperature is below 0 degrees Celsius or 32 degrees Fahrenheit, it is solid. It's held tight together. When the water molecules are between 0 degrees Celsius and 100 degrees Celsius, or 32 degrees Fahrenheit and 212 degrees Fahrenheit, the water is a liquid that is going to roll over and around each other. When you get past 100 degrees Celsius or 212 degrees Fahrenheit, that water vapor becomes a gas, and those molecules will expand in every way, shape, and form. So changing states, if you're going to change from a solid to a liquid to a gas, it requires one of two things: energy in the form of heat or a change in the pressure. So you could increase the temperature or increase the pressure, and you're going to change from a solid to a liquid to a gas. And occasionally, some substances can turn into a plasma. So on your notes, hopefully, you can make this diagram. You want to leave space above it and below it. So changing states. As we increase the temperature from left to right, solid, liquid, gas, and plasma, solid to a liquid is melting, right? You raise the temperature, it melts from a solid to a liquid. From a liquid to a gas, that's evaporation and boiling. And then from a solid to a gas, that is sublimation. And sublimation is there's only one place that we know of that sublimates, and that is dry ice. Dry ice goes directly from a solid to a gas, even though you put it in a liquid to make that happen. You don't have to put it in a liquid, it'll just happen. Going the other direction, decreasing the temperature from a gas to a liquid is condensation. From a liquid to a gas is called freezing. And there is nothing that we know of generally that goes from a gas directly to a solid. Plasma, though, is simply a superheated gas. That's how we're going to define it. You're going to be doing assignments on the states of matter and their transitions. Thanks for watching.